All right, Algebra 2, we're going to actually use the calculator just a little bit for log functions today. So I just want you to get used to where everything is. So here it is, log on the left-hand side for most calculators. For the smaller Texas Instrument, it is along the top there. It's near the top, right underneath the second function. So log of 15, let's just drive that in here. Log of 15. Okay, so I get 1.176. Okay, so what about log of 12? Log of 12, we throw that one in here. Notice I don't, since I'm just dealing with that one single number, I don't really need to close up those parentheses. When I get to the left-hand side, I probably should. How about just log of 5? Log of 5, I got 0.699, somewhere along there. Log 9, again, just trying to get comfortable using the calculator. So log 1,296. All right, so here we are, we're at 3.11. Hey, look at that. That one turned out to be, more than one. All right, so we had some of those log 15, log 12. Okay, so there's definitely something going on with this. All right, now here's what we do. Now what we do is we do log of 3, and I close that up, plus log of 5. Plus log of 5. Okay, so I got 1.176. Okay, how about I try log 2, close it up, plus log 6. I don't need to close that one. 1.079. Okay, let's do log of 25, close it up, minus log of 5. So really just trying to get fluent in using this calculator. 0.699. All right, what if I did 2 times a log of 3? Okay, so let's see here, 0.954. All right, and then maybe 4 log of 6, just for good measure. We get these, hey, there's that 3.11. I thought that one was familiar. Looks like a lot of these were familiar. So let's get this out of the way and let's see what we can figure out. So let me take a look. So when I had log 3 plus log 5, somehow that turned into 15, right? Because these were the same thing each time. Okay, so remember these have to do with your exponents, right? So I see multiplication over here, and that comes from the addition. Okay, so that sounds about right. So what happened in 3? We were subtracting, so it divided. And then the third different rule we have down here, okay, how did it get 2 log of 3 to become 9? Oh, okay, I see it. It's 3 squared. Okay, so we could just double check. What's 6 to the 4th power? Oh, it turns out that's 1,296. All right, so now those were intentionally set that way. Yes, I do want you to be able to use your calculator, but we don't need our calculator for a whole mess of stuff. We're going to practice these 3 properties today. Now, the other thing that we have to show you is if you type these 2 into your graph, right? So y equals log x to the 3rd power. Remember, since this exponent can be a coefficient, this coefficient can be an exponent, we get to interchange those both ways, and that's what our graph is going to look like. Okay, so if you need some more proof, that is your third piece of proof there. All right, so what are these called? They're called the product property. When's it a product property? When I'm multiplying. Okay, it seems really weird because you're going to think, hey, but I'm using addition. But the addition causes the multiplication, so it's a product property. Same thing with subtraction, causes some division, so we call it the quotient property for logarithms. And then the other one is the power property. And what that means is your coefficient and your exponent are interchangeable as we deal with log base b of some number. Now, we used to have all these tables, and some, if you find some older textbooks, you're going to find log tables because the calculator just wasn't equipped to deal with all these things. We just have calculators to deal with that. So a long time ago, so you notice here around 1647, this guy William Altrud, he had a medical issue where he couldn't sleep, right? So he had some interest in science and math. So what he did is instead of sleeping, when others took their rest, he says, when others took their rest, he worked in watching, doing his cold labor. He took logs like we had way up here, and he studied the log properties to say log of 3 plus log of 5 was exactly the same thing as a log of 15. And by doing this over and over and over again, he found that it was always true. So we'd like to thank William for shortening up some of these problems. I know today you're going to think, but that means I have work to do. But it'd be a lot worse if it wasn't for William. Okay, so here we go. We had log base 3. So I changed out the base number. Now, here's the other thing is these bases have to match, right? If I had log base 3 of 20 and log base 8 of 4, this is a no-go, right? We have to have that. So, you know, it's kind of understood up here that these bases are the same to be able to use these properties. All right, so if I see a big old minus sign in here, this should be log base 3 of 20 divided by 4, which is log base 3 of 5. Now, as we do this a few times, you're probably going to skip that step in the middle if you want to. Now, it kind of works like the order of operations. So I know that at some point I'm going to multiply because I see this addition. But before then, I'm going to check for any coefficients. So I have 3. So this becomes log base x to the third plus log of y. And then what happens is my x to the third has to be multiplied by y. So it becomes log x cubed y becomes our final answer. Because we're trying to put these things together. Because eventually we're going to put some equations in here. And remember, if you know what the log is and it's equal to something, then we can start using our ability to change them from log to exponential so we can solve some more complex problems. So we're just trying to inch our way there. All right, so first thing I'm going to do is I'm always going to look for any coefficients. So I see this one here. So this is going to be 2 to the third. So that's going to be log 8 plus log 4 minus log 16. Then I want to work left to right. So I'm going to work on these guys here. So log 8 plus log of 4, that means I should multiply 8 and 4. So that's log of 32 minus log 16. Now I'm going to subtract, which means I should divide. So log 32 divided by 16 is 2. So we go log 2. Okay, so if you're getting the hang of it, we can always start to shorten that up just a little bit. Oh my goodness, I dropped my stylus. All right, so it doesn't matter. It doesn't have to be the very first one. If it has a coefficient, we're going to hang that guy up. Okay, so there we go. So we got log of 8 minus log of 2 squared is 4. So plus log of 3. So next thing you want to work left to right. So log 8 minus log of 4. So that's log of 2 because 8 divided by 4 is 2 plus log of 3. Now that I see addition, I'm going to multiply 2 and 3 to get 6. So it's log of 6. Log of 6. All right, so to prove that you kind of have it to yourself and to everyone around you, and we're going to use the same property, except we're going to expand it. So this one's a little bit tougher, right? Because I have to understand that I have two very different things here. I have an x and a y. So what happens is I have to have log base 5 of x and log base 5 of y. Now, if I see a division problem, that should be replaced with subtracting between these. Okay, so every time I have another factor in here, right? So if this had a 2 in here and a 5 in there, then I would have to separate those as well. Okay, so that's where at first this one's a little bit more confusing. So we'll kind of baby step our way through it, and then we'll give you some big boy stuff. All right, so right now I have 3 and I have r to the 5th. So I need log 3 and log r to the 5th. They're being multiplied, so I'm going to put a plus in here. But I got one more thing, right? I got one more thing in this one. So this 5 should come down here, and then I can take that out. So it should look like log 3 plus 5 log of r, and then it's completely expanded. I know I did it correctly if I can put this back together, right? This will become r to the 5th multiplied by 3, so 3r to the 5th, and that's what we started with. Oh my goodness, the next one's blank. We should make it something crazy. Let's make something crazy. Let's go with log, and I don't want to use a base of anything because that's just going to be crazy talk. Let's go with 5. Let's make it the square root of x. Let's put it over top of maybe y to the third and a z to the eighth. So first thing is, how many different things do I have in here? 1, 2, 3, 4. All right, so I'm going to need log of 5, log of x, log of y, log of z. Now between the 5 and the x, they're being multiplied, so I'm going to use addition there. Now the problem is I have a square root of x, and I'm not really sure what exponent to use for that. But remember, the square root is the same thing as a 1/2 power. So I'm going to put this down as a 1/2. So when I had y to the third, I'm going to put a 3 in front of that, and z to the eighth, I'm going to put an 8 in front of that. Now the next step that we have is the y ended up in the denominator. So I got to use a minus sign right here. Now this is where it gets a little bit hairy, because if I just work left to right, that puts 5 and x in the numerator and my y to the third in the denominator. Well, the next thing I still want is the 8 on the z, so z should also be in the denominator. Now we can make this a little bit different. If I take and say I want to use parentheses, then I use a plus sign here because y and z are being multiplied in the denominator. So I can notate this multiple ways. Both of them are correct. Just be careful as we put them together, and you'll see that through some of the homework. So I'll take either one, either minus minus or minus parentheses, and put plus in between the last two logs. All right, now our calculator, notice when I hit log on the calculator, it didn't really do too much for me. I don't even know where it went now. Okay, because I couldn't change out this base. It might show up here in a second. But here's what happens is if I have just a calculator that can handle log base 10, I can actually use log base 10 if I can match those. And what happens is I take, I use really simple terms for this. I take log of the big one, meaning the one in normal print, log 20 divided by log of the little one, 5. So we can punch that into our calculator. Please do use parentheses on this one. I don't know where my calculator went to, but we want to use log 20, close it up, or hit enter, and then divide it by log of 5. Don't have to close that one. So if you're getting 1.861, then you did okay with that. Okay, so up here, we got log over log. So this is a little bit different property. This means I only have one thing to work with. Hey, there it is. And this time we want, let's move this guy over so I can show you guys what's up. And we got log of 5. I do want to close that up, divided by log of 8. Okay, so 0.774, 0.774. Okay, so 5 over 8. Remember, we're going to take kind of the big half here and then the lower half there. All right, so very different. Remember, this does not have to do with subtraction. Don't get that subtraction division part mixed up. So that's kind of what we'll deal with here. All right, so can we rewrite these? Remember, the first thing we'll look for is do I have the same base? And this answer is no. Okay, the base are not equal. All right, 2 is not equal to 6 in the base. All right, expand each. Okay, so that means I want to take these apart. Expand means take it apart. So log base 2 of 7 plus log base 2 of b. All right, the next one, notice the whole thing is squared. So what I typically like to do and encourage my students to do is match what's going on here. 2 parentheses, log y and log 3 parentheses, because if all of it's in parentheses, let's leave it all in parentheses. If since we're dividing, we're going to subtract. Okay, my other option is to write 2 log of y minus 2 log of 3, no parentheses there. Okay, so I kind of match whatever the problem is given. Okay, so I got log of 7a. Remember, that was to the third power, so they were going to drop it in there. We're multiplying, so plus 4 log of b. I almost forgot my base 7 in there. Do have to have those as matchy-matchy. All right, so we get into some homework. I put a ton on here because as you do them, you're going to find out that they get easier and easier and easier and easier. Okay, but if you're not in my class, guess what? You don't have any homework. But if you are in my class, come on, man, do the homework.